Hello everyone, welcome to another episode of On the Grok Talk. Today we have with us Mohit Bhat. He is a blockchain developer at Accubits and also a GSoC mentor. He is passionate about the technology of blockchain and we're very excited to what you have to share with us, Mohit. And I will you.
Thank you, Pratik, for the invitation. Let me share the screen.
Sure.
I hope it's visible, right?
Yes.
Yeah, so uh, hello everyone. I am Mohit Bhat and I'm basically a blockchain developer, a software development engineer at blockchain at Accubits Technologies. In past, I have been in Summer of Bitcoin and Google Summer of Code programs, and this year I am also a GSoC mentor, GSoC 22 mentor for one of the open source projects of which is on Mint NFT and a node cloud. I'm also a blockchain speaker and educator, and in past I have given multiple sessions on blockchain. So today I would be talking about layer 2 scaling technologies, which is basically, you might have heard about side chains, plasma chains, ZK rollups, optimistic rollups. We would focus more on ZK rollups and optimistic rollups. So let's get started with the session. Okay, so let's first understand why we need scaling solutions. You might be thinking of we have Ethereum blockchain, we have Bitcoin blockchain, we have a lot of blockchains coming in the market, and then we also are hearing about some layer 2 and side chains coming up in the market. So many of the people confuse about what is the reason behind building these such kind of scaling solutions, layer 2 solutions, and many people confuse between layer 2 and side chains. So first of all, let's understand why we need scaling solutions. So currently, in Ethereum, lots of applications are being built. Okay, and we are trying to transit from web 2 to web 3. We are trying to make applications that are present on web 2. We are trying to convert them into the web 3 format, and for that, we need high throughput, we need less cost, okay, and we need high efficiency of the transactions that are happening. Because if you are building a smaller web applications, maybe let's say you are trying to build a Ola or Uber on web3, then in single second there are multiple cabs being booked. So for that we need high throughput blockchain. Though many new layer 1 blockchains, I mean the Ethereum and Solana, these are coming and trying to solve this problem, but still once they come in the market, it's not easy to build like that much of efficient blockchain which can handle so many transactions. Because the architecture of blockchain is like that, we are peer-to-peer connected, and we have to exchange data, we have to exchange network calls and all that. So what scaling solutions does is we basically have a parallel chain running where we do the transactions, and ultimately we basically put all the data that we are doing, all the transactions that we are doing on layer 2, we are putting it into the layer 1. So what it how it helps. So first of all, we have less congestion on the layer 1. So you can think of layer 1 as the main road, and layer 2 and these other technologies as the side roads, smaller roads. So we basically are moving our cars on the side roads, but which basically ultimately uh, like uh, goes to the main road only. Okay, so that is what layer 2 does. We are building parallel blockchains which are dependent on the main blockchain. Let's say, take the example of Ethereum. So we are building a parallel blockchain, and we are doing transactions on that second blockchain or parallel blockchain, you can say, and then putting all those transactions in a combined, we are aggregating those transactions and putting on layer 1. So what it does is it is basically reducing the congestion on the layer 1 technology. Ethereum gas price and is increasing like day by day. So we have to decrease the congestion so that we can do more and more transaction at less cost. And as I said, like there would be less cost always. Okay, you are not doing at the main chain, you are doing at the side chain, which will have less people, more efficiency, and more new kind of stuff being included, which reduces the cost. Then we have like greater speed and efficiency, as everyone is not doing transactions on a single chain. Okay, not all cars are running on the same road, so that's why the speed and efficiency increases. So there are like sub chains on which we are doing the transaction, so that will basically automatically increase the speed of the transaction. And then we can build better tools and blockchain capabilities. Ethereum is set, and to like implement more things on Ethereum, we have to fork that chain. Like the Ethereum 2.0 is coming and they are building, but see, it's taking a lot of time. But if we are able to build more layer 2 solutions, so we can implement new stuff on layer 2. So that will increase, like that will bring actually more and more opportunities for the application developers to do the stuff. But if we are on a single chain, then migrating from new one software to another software is very problematic also. So some of the scaling solutions that are in the market, okay, there are many, but these are few of them. One is Sidechains, another is Plasma Chains, then is ZK Rollups, and then it is Optimistic Rollups. So Sidechain and Plasma Chain, you might know about it. You might have used it also. That is like Polygon. So Matic Network, which was previously Matic Network. So Matic Network is a sidechain basically. Okay, it's not a rollup. It's a sidechain, and basically sidechain. We will talk about what's the difference between all these four. But you can think of like uh, Polygon also has actually a plasma chain, plasma bridge. You might have heard about proof of stake bridge and plasma bridge. So these are some of the scaling solutions that are in the market, and we will be talking more about uh, in time to come. Yeah. So let's start with the side chains. First of all, let's understand what a side chain. So this idea of sidechain was basically like published first time in like 2014, okay, and it was applied to Bitcoin also. Okay, you might have heard about Lightning Network. It's a kind of sidechain for Bitcoin. So sidechain is basically like new chain, okay, a parallel chain which has its own consensus model, which has its own validators, which has its own miners. Okay, it's basically Ethereum is working, and then we have Polygon. So Polygon is sidechains. Polygon has its own consensus model. They have implemented proof of stake. Ethereum is on proof of work, but Polygon is on proof of stake. They have own validators and all of those things happening on that chain. Okay, so it's, you can think of a kind of like a separate chain. And then how we talk between Ethereum and Polygon, we talk with the help of bridges. Okay, so bridges is just like you can think of smart contracts deployed on both chains to talk to each other. Okay, and we are building some centralized bits so that they can talk to each other. But the problem with sidechain is like we cannot uh, provide a greater security in sidechain, because let's say if all the validators, if all the miners on this sidechain says we do not want to run the network, then all your assets are locked in the sidechain. Okay, because you are not using Ethereum in any sense. It's basically a totally different parallel chain working, and you are doing transactions on that chain. Then you have built a bridge. That's fine, you have built a bridge to talk to one another, one chain to another chain, but still you are basically transacting not on Ethereum, you are transacting on a some different chain built by some people. Now coming to the plasma chains. Okay, so plasma chain basically was like uh, brought in like in 2016, was published in one of the paper in 2016. See, plasma chains are also side chains. Okay, it is a totally uh, like a new chain with its own consensus model, with its own validators or miners. You can, okay, but there is one thing that is providing an extra security over the normal side chains. that is like whatever transactions you do on plasma chains, you ultimately take a snapshot and put it on Ethereum. Okay, you put it on the layer one chain. Okay, so if I just give you an example, it's like if there is a Polygon plasma chain, okay, and you are sending someone one ETH on plasma chain, and let's say after some time the like the validators of plasma chain says, okay, we don't want to run this network. Okay, it's not a good network. So still you can ask for your like that one ETH you have transacted, because there is a snapshot made. Okay, snapshot is basically like 15-20 transactions we are jumbling up in a Merkel tree and putting a snapshot, the root of that transaction, onto the Ethereum. So basically plasma chains continuously do some transactions to the Ethereum. Okay, side chains, like normal side chains, doesn't do that. Okay, they are just running parallelly, they don't have any connection, or they are not putting any data or any snapshot on Ethereum, but plasma chain does. Okay, whatever transactions you are doing, they will take snapshot after, maybe let's say, take an example, 1 hour. Okay, 1 hour, these many transactions are done, they arrange it in Merkle tree. Okay, take its root and put it onto the uh, to the Ethereum. So now Ethereum has some copy. Okay, this is a snapshot. It has a copy. Okay, some transactions were done on this chain. So it proves like, and then you cannot like you have the security of Ethereum. You cannot change that proof from the Ethereum. Okay, so in this way, plasma chains are actually more secure than single side chains that are present. So that is the difference between plasma chain and side chain. And I think if you want to like do a lot of transactions and you are building some great amount of application, you should, if you have an option between side chain and plasma chain, you should choose plasma chain, because it provides better security. It has a kind of snapshot, or you can say a kind of a connection with the Ethereum, so that let's say the particular plasma chain uh, just stops working due to any reasons or get hacked or something, you still have a snapshot, a proof on the actual blockchain, which is Ethereum, that you have done something on this particular plasma chain, and then you can ask for refund or something like that. So basically, whatever layer 2 solutions we are building, we mostly want the power of Ethereum with us. Okay, I will be talking mostly about the Ethereum here. That is the well-known public blockchain. So we are trying to build side chains, layer 2 technology for Ethereum to scale it up. So we always want like we are in a way connected to the Ethereum, so that whatever transactions we do, it has the security model that Ethereum is providing. Okay, so that is our goal when we are building these side chains or these layer 2 technologies. So this is a example here that whatever transactions are happening on side chain, ultimately using the smart contracts, there is a bridge. You can think of this as a bridge. You provide proof of locked assets on main chain, and then if you want to withdraw, you provide proof of locked assets on side chain. Okay, so in this way they are interconnected. Just this is the example of side chain. So
Mohit,
yeah,
just a quick question here.
yeah,
So you're mentioning in sidechain, so there's we don't have the snapshot, right?
yes.
Like in a plasma chain. So how are they actually connected to the main chain, and how are they ensuring that the data is on the main chain?
Okay, so basically side chains do not ensure that data is on main chain. Okay, they are like separate layer 2 working. Okay, as I said, they are separate chains working. But to converse with the main chain, if you want to transfer assets between Ethereum and let's say this is side chain one, if you want to swap assets between these two chains, then you make bridges. Bridges are just like let's say you want to transfer USDC from Ethereum to sidechain one. So what you basically do, there is smart contract present on main chain, okay, on Ethereum. So you basically send those you send those USDC to the Ethereum, okay, to that smart contract and lock it up. So that is what I am providing. You just basically lock that asset on the Ethereum, and then there is some listener working that may be mostly centralized only, okay. uh, like some blockchains like Polygon has made decentralized, that kind of stuff, but like they're mostly centralized, that listen for, okay, something is logged on Ethereum, now they issue same number of USDCs on the sidechain one. So that is how you basically send assets between one chain to another, and that is the case of sidechain. They do not provide any, they do not ensure any, like the whatever transactions that are happening on sidechain, their copy is being submitted to the Ethereum. That is not happening in sidechain, but plasma chain does that. So whatever transactions you do on plasma chain, they put a copy of that, not whole data. They just put it in, they put the snapshots and put it into Merkel tree and then put it on the Ethereum. So they provide, they ensure that like data is, data proof is accessible on the Ethereum chain also. And because of this reason, that plasma chains are more secure as compared to side chains. I hope you.
Right. Right. So why are they actually being, referred to as side chain? I believe that's just another chain. Why is it a side chain?
Mostly why they say as a side chain, because they inherit the, like some of the properties of the main chain, okay. They are built to provide transfers between Ethereum only, okay. If you want to build a layer like a side chain for Bitcoin, you cannot use Polygon for that, okay. You have to use Lightning Network, because the underhood, the model of that, the underhood model of that particular side chain is based upon Bitcoin blockchain. So that's why we call them as side chain, okay. We do not call them as a separate chain, because they inherit the model of the main chain, the parent chain they are working on. So, and then bridges will only work if they are dependent in a kind of, under the technology, on the basis of technology, they are dependent on the parent chain. Yeah.
Okay, so they have a similar kind of an architecture, the
Yes.
side chain and the main chain.
Yes.
And this making a bridge is only possible if both the architectures in there, not just between any chain.
Yeah. Yes. Right.
Okay, sure. We can go.
Yeah. Okay, so this is the example of Polygon. Okay, Polygon actually has more security. It's, as you know, it's like it has plasma stuff also. So they put snapshot on Ethereum. They put checkpoint. They have checkpoint contracts. Okay, they have staking contracts, which is like basically for rewards and validating stuff on Ethereum main chain. But they have like this Hemdall, which is basically the proof of stake architecture that is working on Polygon, and we basically, whatever transaction is happening, these are the block producers. Okay, whatever transactions are happening, they gradually put everything as a checkpoint on the main chain. So Polygon is like in that sense more scalable, but if you just go through it, it's basically a side chain. It doesn't use ZK rollups or optimistic rollups. Uh, but currently, as you know, like the Polygon technology, the whole Polygon technology is building that kind of solutions on rollups, using the rollups, and that provides a greater security. Like with the applications that Polygon is coming up. But if you just talk about the Matic network, that is the proof of stake chain they have, uh, it's a little secure, I would say, not too much secure. Okay, because they have checkpoints, that's why they are secure. But ultimately, it's a side chain that is working behind the Ethereum. Okay, so now coming to layer two. Okay, there is actually difference between what we called as side chains, plasma chains, and layer two. Layer two we call as, which basically inherit the security model of the parent chain. Okay, side chains and plasma chains are parallel chains working, and they have their own consensus model. Okay, they have their own validators, they have their own stuff going on. But layer 2 are those chains. Okay, it is again like you can say another chain working, but layer 2 doesn't have any own inbuilt consensus model. Okay, they rely on the parent chain. They are basically uh, doing things on the Ethereum or whatever Bitcoin their parent chain is. They are not like having their own consensus model like proof of stake or proof of work, or they do not have their own validators like that is present in the sidechain and plasma chains. They are just totally dependent and inherent the security model of what their parent chain in like parent chain is, but with higher throughput, higher security, and with a unique way of doing transactions and putting proof of those transactions on the layer 1. That is what makes them more efficient, more secure. And the idea behind all these roll-ups and optimistic roll-ups and ZK roll-ups is behind the layer 2 only. So as I said, the significant difference between layer 2 and this is like sidechains have their security mechanisms of their own, but layer 2 solutions derive their security from the parent chain. That is, if somebody asks you like what is the difference between these two, this is the main difference. And many people actually confuse between sidechains and layer 2. They say like it's same thing. Many people think like sidechains and layer 2 are same thing, but they are not. So some if some application or like if a new blockchain has come and they are saying they are sidechain, just just understand that they have their own security mechanism. But if some uh, uh, blockchain says they are layer 2 solution for a particular blockchain, then just understand it. It's basically they are deriving from the parent blockchain, and they are way more secure than side chains. So that is the one thing. So
Uh, so, Mo-
yeah,
so what? All layer two are plasma chain, is it?
uh, layer 2 a kind of plasma chain. It's not fully plasma chain. You cannot say it's plasma chain because they have plasma chain also has its own consensus model. Okay,
Okay.
plasma chain just differ from side chain in one sense. It puts checkpoints, it puts snapshots onto the Ethereum chain. So that is only the difference. But between the layer 2 and plasma chain, the difference is layer 2 blockchains doesn't have any consensus model of their own. They are dependent, they just do transactions, okay, aggregate it and put it on layer 1. So that is their work. Okay.
So Mohit, however, like if there are like 20 transactions
Mhm.
after which they interact with the main chain, the layer two. So even for those 20 transactions, they need some kind of a consensus mechanism to
Yeah.
uh, they need their own consensus mechanism in that way, or how does it work?
Basically, there are like sequencers, block producers, which handle these things. Okay, we cannot call them as a consensus model. Okay, because like it's not like nodes working like that. Okay, it's a bit different. They have sequencers, they have block producers which aggregate these transactions and then combine it up and then put it on the layer 1. So we cannot call it as consensus because everyone doesn't have to come on consensus on that chain. Okay, it is like we are basically putting ultimately a proof or something like that on layer 1. So we are basically relying on the layer 1 security, not on the layer 2 security.
Okay, so for the layer two chain would collect all transactions. So
Yeah.
if there are conflicting transactions in
Mhm.
the set of 20 transactions, how is that resolved?
So basically, we have like I'm just coming on to that part in some
Okay.
time, like how they do it. Basically, if I just give you an overview of that, we have snapshots present. Like there is like difference how they work in ZK. rollups and how it works in optimistic rollups. Okay, that is what makes them different. How they come on to the conclusion and how they prevent misuse of the things. It is just like in one you submit a challenge, and in one you basically use ZK snark technology to create proofs. So I will just come up in some time onto that part, how it is happening. Yeah.
Sure. We can go ahead.
Yeah. Okay, so all these things basically are possible only because of Merkel trees. Okay, like whatever I am saying, like they are able to put snapshots, they are able to put checkpoints and all that. They basically do it using the Merkel trees. Okay, so they create Merkel trees of the data. Okay, the data, and then they put the root hash into the smart contract. Smart contract is basically what is used as uh, the snapshot point. Okay, it is not like you are directly putting into the blockchain. You are not putting into the Ethereum. Basically, they deploy a smart contract on Ethereum, which basically on which we basically submit this data, and we store data through these smart contracts, not directly like you are sending a transaction from A to B or something like that. You are using smart contracts there. But layer 2 is basically aggregating data and putting it on, putting a Merkle tree data and then submitting that data as a call data onto the layer 1 in that smart contract. So that is what this technology, how this technology is being used, and how it is very important in part of building these layer 2 scaling solutions. So if we come up now on the rollups. Okay, so which is called as the layer 2. Okay, the layer 2 are called as the rollups that we currently have seen. So the first of all, let's understand what are the three properties that make layer 2 rollups uh, uh, the main uh, thing to use in the current space, and it is their market size is also increasing. Whatever layer 2 rollups are coming up, you might have heard about Arbitrium, Mattis, and all these layer 2 technologies, and their market size is increasing, and people are shifting from these side chains and plasma chains mostly to the these kind of rollups. So first of all, the thing that makes them different is like the gas fee is reduced a way a lot. Though that is true on side chains and uh, those plasma chains also, but uh, rollups actually reduces gas fee a lot. That is because we don't have to put all the data on the layer 1. Okay, that was the case in maybe plasma chains or side chains, but that is not the case here. You just basically create a proof. Okay, using a technology called in case of ZK rollups, it is called ZK snark. Okay, so with that technology we basically create a proof, and we do not have to put the all the data on layer 1 to verify it. Okay, then like as I said, the data and proof of transactions reside on layer 1, so it maintains the security. It is not like your funds can get uh, seized or like locked if the parallel chain stops working, or it is like some flaw is there. So that is not the case. uh, your data and proof of that data resides on layer 1. And then coming to the third point, that is the rollup smart contract. Okay, there is basically again a smart contract deployed, which is called as a rollup smart contract, which basically handles this all this data, whatever we are saying that we are submitting a proof, we are submitting data. So a rollup smart contract is there, and this basically enforce proper transactions. Okay, so you also had a question like just Pratik, that how they are maintaining all this stuff, whether the transactions are happening in line. There are 20 transactions and happening, and maybe there are fraud transactions in them. So it is also due to the use of smart contracts. So smart contract has the recent snapshot, the recent proof. So then we build on top of that proof. Okay, the next transaction should happen like this. Basically we are submitting proof of state. Okay, whatever the state transition is happening. Okay, The current state is I have 1 ETH. Then the next state is I have 3 ETH. Okay. So we submit basically the proof of this onto the rollup smart contract on layer 1, and it saves it. And then after that, like let's say I am sending that 3 to someone else, then we are also checking it from the smart contract, that proof that we have submitted. Okay, is the state transaction correct or not? Is like state transaction from 3 to 3? Okay, are we sending only 3? It's not like we have only 3 Ethereum with us, but we are sending 5 Ethereum, because the proof will say, okay, we have only 3 ETH and we are trying to send 5 ETH. So that transaction go will not be proceeded, and that will just basically fail. Optimistic does this in a different way. In optimistic, we basically have 7 days challenge period. Okay, we basically submit transaction onto the smart contract, on the roll of smart contract. But if in 7 days, if somebody says, okay, this transaction was incorrect, he can submit a challenge. Okay, and if he wins, he gets the amount, that whatever amount that was staked, and whatever amount was sent, so he gets that logged as a like a reward, or you can say he will get a reward. But the thing is, like, there is a 7 day challenge period in optimistics things. In ZK rollup, this is not the case, that I am just coming up. So if you see the ZK rollup transaction, how it happens. So this is layer 1, okay, blockchain Ethereum. Then we have real 2 rollup. Okay, so user do transactions. So we basically, multiple transactions are happening here. We batch the transactions. Okay, we batch the transactions, then we create a stock proof. Basically, we create a stock proof. Okay, and then we submit it on the Ethereum. Once it is submitted here, your transaction is successful. But the thing is, how it is increasing the throughput and speed for the users. Basically, as soon as they submit transaction here, their transaction is almost over. Okay, and once we batch it and submit it to the L1, we submit basically the proof. We do not submit all the data. Okay, we do not submit all the data that is that person is doing here, whatever amount he's transacting. We basically generate a proof, stock proof, stock proof or stock proof. These are two different zero knowledge uh, technology. And if we talk about what exactly it is, okay, what exactly is ZK Snark and ZK Stock, what it basically is a technology that provides a feature that is like, it proves that some computation was done with some this particular output, but you do not have to provide the data with it. Okay, it just provides a proof that a computation was done and this was the output of that computation, and it provides that proof in such a way that it can be verified easily later on. Okay, it is a bit mathematical. Okay, there is underhood with mathematical. This is a, you can say, a kind of cryptography that is happening here. And zero knowledge, if we talk about what zero knowledge says, zero knowledge says, like, all the transactions on Ethereum are happening and all the data is public. Anyone can view what data you are storing in smart contracts, what you are doing in smart contracts. So, but zero knowledge says we want to do transactions, but we don't want to store data, the actual data on blockchain. Okay, because there can be my PAN card details, there can be my Aadhaar card details, and we want to use Web3 solution. But if I put PAN card and Aadhaar card details on the blockchain, then anyone can view that until and unless it's a private blockchain, and private blockchains are not secure. That's a simple thing. We need public blockchains, but a way such that we are doing transactions, we are doing blockchain transactions, but uh, the data is not there on the blockchain. Only a proof is there, and that is what ZK Snark research and this ZK Snark technology has come up with. It is a bit mathematical. So what it does is, like, you provided data. Okay, you provided some kind of function. Okay, this thing I have to do. It basically computes it and generates output and a proof, and it says, okay, this is the output and this is the proof. Okay, proof is for like computation that I have done something and this output was there. And but now you don't have to provide any data to verify it. Okay, it is just like LHS is equal to RHS. You are proving it. You are not providing X and Y and Z. You are just able to prove that LHS equal to RHS. That is what ZK Snark technology is doing. Talking about how ZK Snark works under the hood and all that stuff is not possible currently. But yeah, ZK Snark, you can just think of, I don't provide you data, but I am able to prove you that LHS is equal to RHS without providing the data. Okay, it is because of the proof that we have. So that is what ZK rollup transactions are doing. So user do the transaction, we batch up the transaction and submit that proof on L1 block. And then when we are doing the next transaction, we have the straight transaction proof with us. People do transaction. We basically verify, okay, the current state is able to change to the next state. Okay, it is correct form. If it is, yes, everything is done, and then the proof is again submitted to. So in this way, we are basically using layer one security because it doesn't. It is basically a batch technology. We are basically just batching the transactions and doing some more stuff here. But ultimately, we are using security, consensus model, everything of layer one. So that is how ZK rollups work.
Right. So Mohit, just I think couple of questions for you here.
Mhm.
So you're saying that the transactions are submitted in the form of a batch.
Yeah.
So let's say in the batch itself,
Mhm.
in a particular batch, I have three, but I have two transactions
Mhm.
in the batch. In one, I'm giving away two each, and in another transaction, I'm giving two each to someone else. So I'm
Uh-huh.
spending four each, although I
Mhm.
have three. So this batch of transaction is submitted to L1. So where is it like corrected? Is it corrected in layer two itself, or is it corrected in layer one? Where
Yeah,
is
in ZK rollups, it is corrected in layer 2 itself. Okay, they are like synchronized because layer 2 also keeps a note of what is happening. It is not like they are not put, because data is with off chain. Off chain, I would say the data is with layer 2 only. Layer 1 doesn't know any data. Layer 1 only have proof. Okay, layer 2 handles this data in ZK rollup, not in optimistic rollup. In optimistic rollup, layer 2 handles, but we will talk about more about that. But in ZK rollup, layer 2 actually handles all the data. Okay, it computes, it proves it. Okay, LHS is equal to RHS. Okay, we are able to generate proof, everything is correct, and then submit to the L1. So all that stuff, batching of transactions that I am saying here, that is done by layer 2, and it also knows, okay, what is the current state of layer 1. Okay, when we start the layer 2 technology, we have what is the current state of Ethereum blockchain, and from there we basically start our transactions. So that is how it's happening.
right? So Mohit, although I'm not an expert on blockchain technology, but from what I understand, so this is basically a double spend problem, and the consensus mechanism that we have, proof
Mhm.
of work, proof of stake, they're essentially one of the things they solve with double spend, right?
Yes.
So how is this double spend being solved in layer two? Because they don't have their own consensus mechanism, is it? How do they solve a double spend in layer two itself?
See, the thing is like in layer 2, if they submit multiple transactions, as I said, the if they have like double spend transaction, that one person is doing transaction to the second person and then again he's trying to send it to the second person. So in layer 2 only, like we have, as I said, we have sequencers, block producers. Okay, if I just show you here, like we have these relayers. Okay, user 1 is doing transactions and user n is doing submitting the transaction to the relayer, and relayer actually batches the transaction. Okay, checks, okay, the transactions are aligned, if there is double spend, if there is something, it is the work of the block producers and layers. And if they do something that is not correct, okay, there are we do not call it as validators, okay, because that is for proof of stake, but we call it as layers and block producers. which basically take these transactions. They see, okay, everything, it is their work, okay, everything is aligned and everything is done or not, and then they generate proof and submit it. But the thing is, like, if they submit a wrong proof, okay, on layer one, the consensus fails, and once consensus fails, all these transactions, whatever the relayer submitted, gets out. Okay, you cannot submit a wrong transaction. Basically, you would not be able to do a transaction on Ethereum on the layer one if you submit a wrong proof, because you would not be able to generate a valid proof if your transactions are not aligned, if there is double spend, if there is something like that. So mostly relayers would not do that. That is how blockchain also works. Okay, we cannot say it's a full consensus. Okay, a little of consensus is there, but it is just like the layers, block producers, and all those people have to manage those transactions, have to batch those transactions in a correct way, and then submit the proof to the layer one technology.
Okay, so if at all there is a malicious this block producer
Yeah.
and it is trying to make a false block, then layer one would not accept it because the
Yeah.
proof will not.
Yes, and there would be some another layer that would be submitting also the proof. Okay, there are multiple layers. It is not like single layer happening. Okay, it is not single layer is there or single block producer is there. There are multiple layers and block producers which are working simultaneously, and whosoever wins, they get rewarded. Okay, so here also that kind of stuff is there that is present on layer one, but it's a bit different. They don't have to do everything. Okay, you don't have like this all that stuff. They have to stake some money. Okay, I would not do it. Okay, they do it on again on layer one only. They stake money on layer one smart contract only. If we just talk about Polygon Nightfall, okay, that's coming up in the Polygon Nightfall. There are like proposers, challengers, liquidators. These kind of entities are there. Okay, these kind of nodes are there. So proposer is like which proposes block. Then there is like liquidator which liquidates. And so all these nodes, or you can say, are working simultaneously, which basically generates these proofs and submit it to the layer one.
Okay, understood. So also with the ZK snarks, so
Yeah.
how do you mean how does that actually work? So it does not it doesn't we don't have to give the inputs, right? We don't have to show input. We can just prove that output is correct,
Yeah.
right?
So,
That's
yeah,
what they essentially do.
when you are generating proof initially, then you provide input. But to verify it, you do not have to provide input. Okay.
Okay, so it just works. It just verifies the output,
Yes.
and as you mentioned, it can verify that computation has been done
Yes.
to get that output.
Yes.
These are the two things that it confirms.
Yes. To generate a proof, you have to provide data. And once you generated proof, okay, uh, the state is 1, 2, 3, and this is the proof. And then you can verify, okay, this output is correct using ZK Snark. But you don't have to provide data again. Okay. So that is how it works.
Okay. Okay, understood. We can proceed. Thank you.
Okay, so we were here like about the ZK Snark, and we talked about how it works. I hope you can deep dive into ZK Snark, or maybe in another series we might talk about the ZK Snark also, how exactly under the hood it works. So coming up to like the types of rollups that we currently have been talking about. Rollups, as you know, is like useful in reducing fees and increasing transaction output and expats participation. There are two kinds of rollups. One is optimistic rollups, and then there is ZK, zero knowledge rollups. Zero knowledge, ZK snark means I am hiding data. Okay, I am just submitting proof. And zero knowledge, I think, is like technology that is being researched rigorously in the current space, because if you want if you want like enterprise adoption of blockchain, then zero knowledge is a key in that space. Because if your data is open, then enterprise are not willing to come on to the blockchain. They want a technology, they want blockchain in such a way that their data is not uh, like visible on all these chains, as their competitors might also be going to know, okay, what what transactions they are doing and what's happening in that company, and that is not like a good space for enterprise entities. So yeah, zero knowledge is something that is uh, uh, a need of an hour, like in the blockchain space, and it is, and currently we have reached to the point of zero knowledge rollups, and Polygon is coming up with some new technologies which has like these private transactions. I will just talk a little bit about that also in the end, so what that technology is. So currently, let's deep dive into these two different rollups: optimistic rollups and zero knowledge rollups. So optimistic rollups assumes transactions are valid by default. Okay, the main difference between these two are zero knowledge rollups basically like do the computation. Okay, do the computation, generate proof, and then submit it. So it does everything beforehand and then submit the final thing. Optimistic rollups, they also like batch transactions, do the stuff. Okay, they do everything like that, but they doesn't generate any proof. Okay, they doesn't verify it. They just basically align it as far as they want. Okay, they just basically all the valid, all the like sequencers or block producers, they align those transactions in a correct way, but they do not verify it in any sense. They just submit it. They submit the root of that Merkel tree, whatever transactions are happening, to the Ethereum, to the layer one. After that, they provide 7-day challenge period. So what that 7-day challenge period is that it is like if that particular uh, route that was submitted, whatever state transaction thing was submitted to the layer one by optimistic rollup, if somebody says okay, these transactions are not correct, and that can happen because block producers can be malicious, right? So they can do something wrong. So there are challengers working. Okay, so those challengers have 7-day period. So if they find okay, this transaction was not correct, this submission was not correct, so they can submit a fraud proof, which is basically uh, okay, this transaction is not correct and I am submitting the fraud proof, and they have to stake some money also. Okay, they have to stake some tokens, uh, because if their fraud proof is correct, they get back this tokens and they get the reward also. And if the fraud proof is not correct, then their stake is taken back. This is just to reduce spam in while submitting fraud proof. Okay, so it is just basically the difference between these two, if I just sum up, is zero knowledge does verification computation beforehand and submit the proof to the layer one. Optimistic rollups doesn't verify it. It does everything like that, but it doesn't verify or generate any proof. It just submits it to layer one. There can be chances that it just assumes like all transactions are valid. There are now challengers work to submit like a challenge. Okay, this transaction is incorrect, and they have to prove that. They have to submit a fraud proof. Fraud proof is submitted using Merkel tree and some data. Okay, they provide okay, this is the data, this is the fraud proof. They have to generate a fraud proof and submit it as a transaction in the smart contract that is deployed on layer one, which is the roll-up smart contract, as I said before. So if that is valid, then all transactions are rolled back in optimistic rollup for that particular thing. Okay, and then whatsoever like whosoever has submitted the wrong transaction, block producer or sequencer, whatever, they get penalized and banned, and challenger gets the reward. So that is the way how optimistic rollups and zero knowledge rollups work. So if we just go into like in such kind of thing only, again the back. Yeah.
Right. Mohit, just one question with optimistic rollups here.
Yes.
So you mentioned 7 days, right?
Yes, 7 days.
As a challenge period. So in essence, someone would have to wait 7 days to actually be convinced that the transaction is final, right?
Yeah, yeah. So that is actually a negative point of optimistic rollup. If we talk about the disadvantage of optimistic rollup, that is the thing. And the thing is like you cannot withdraw till that time also. Okay. So let's
Right.
say on layer two, you are submitting, like sending someone money, and he wants to now withdraw that one ETH from uh, this layer 2, from optimistic rollup chain to layer 1. Okay, he cannot do it for 7 days until 7 days has passed for that transaction. Once 7 days are passed, then only you can withdraw uh, like those tokens from optimistic rollup. That is basically a negative point, or you can say disadvantage of optimistic rollups over zero knowledge rollups. But there are some advantage and disadvantage both, because zero knowledge rollups take a little more gas fee as compared to optimistic rollups. Okay, because you have to submit proof and all that. You have to the call data is increased, and a little bit transaction time also increases in zero knowledge rollups as compared to optimistic rollups, because optimistic rollups just aggregates and then submit. So yeah, that is at the negative point of optimistic rollups.
Right. So also another thing with optimistic rollup. So let's say there's one transaction today. So the next transaction would accept this transaction as true, right? In order to
Yes,
go,
yeah,
I.
yeah.
So if the challenge is on the sixth day, then we will have to roll back 6 days of transaction, right?
Yes, that happens. Yes.
Okay. So then after that, all the transactions are nullified, and then we go back 6 days.
No, 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 not
No.
nullified. Whatever transactions were incorrect in that, then they again get bashed by block producers and all that, and then they submit it again. It is like automatically it happens. It is not like everything is rolled back. Okay, that particular transaction is taken out by the block producers or challengers, and but yeah, it gets rolled up back. That is a negative.
Okay. So just the incorrect transaction and whatever happened after that. So
Yes.
I give you two each. Maybe
Yeah.
that's wrong.
Yes.
And
Yeah.
you give that two each to another one,
Hmm.
someone to another one. So all those transactions will be rolled
Yes.
back.
Yes.
Okay, okay, understood. So it's not clear to me why would they give such a long period, 7 days, and I see a lot of like challenges in optimistic rollups. What's your point on that?
Yeah, so see, many people, like as I said, everything comes up with some advantages and disadvantages. I think the future is with like a mix of zero knowledge rollups and optimistic rollups. Okay, I think it would be a mix of both, and many people say it also. But yeah, optimistic rollups has negative point in this case, that we have to wait for 7 day challenge period. But at the same time, it provides very fast transactions as compared to zero knowledge. Okay, because in zero knowledge you have to generate proof and all that. Optimistic rollups are very quick. So there is like trade-off between security, speed, and all that. So everyone is trying to balance and trying to work on it, how they can improve it. So in
Right.
some,
Perhaps, yeah.
yeah.
Perhaps depending on the use case, we can decide what works better.
Yes, exactly. Yeah. Yeah.
Sure, sure. Thank you. You can go ahead.
Yeah. So this is again a kind of roll up transaction only. I think we just covered it up. So if we just deep dive into that, this ZK rollups and optimistic rollups. So there are batch transactions, there is mempool, okay, and then there is ZK proof computing power, okay, that is working on. So this layer two builder basically have called it a pre-state root, post-state root, ZK proof, KZ commitment, okay. It provides all that transaction here, then transaction batch provides it here, and then submit the roll up to the uh, like the state root, okay. It generates a state root and submit it to the roll up contract. In every sense, many people think, okay, how they are doing, how they are these built. Many like students and think like, okay, how they are submitting it. They think like there is some connection between, there is like direct connection between RPC links and all that. It is not like that. On Ethereum, these layer 2 solutions are basically using a contract. If you want to build your own layer 2 solution also, you can also build it using, you just have to make that smart contract a good smart contract, which you call as a roll-up smart contract, and you have to define all those parameters, commitment, proof, all that things. These all things what I am saying, like submitting proof, challenge, all these things are basically functions in smart contract. Okay, it is not like something like many people think it very difficult. Okay, they are building like that. No, it is just a smart contract. I though you can think of like smart building smart contract, that kind of secure smart contract is a bit difficult in starting, but ultimately it's just a smart contract. Again, the logic of normal applications you build. Okay, and in that smart contract you have these state functions, challenging functions, and submitting functions, fraud proof functions. So these functions are in those smart contracts, and you basically allow these L2 builders to call those smart contracts. So that is how these rollups and everything work. So this is the example of Polygon Herms, which is a ZK rollup solution. You might have heard recently also that they have, this is acquired by EY blockchain. EY has built Herms, and this was acquired by Polygon. So what Herms does is like it have 2000 transactions can like be processed in a single batch. Okay, Herms, then basically they put a validity proof, they generate a validity proof, as I showed before how it is generated, pre-state root, post-state root, ZK proof of this thing and this thing, and then they submit it to the Ethereum layer 1. And and it is like 15 validity proofs can be included in one layer block. Okay, basically you can submit 15 validity proofs. You know, like Ethereum takes some time, so you will not wait for those many transactions on Herms. So Herms is continuously doing transactions. You are batching up and aggregating and submitting, and it is like a lot of transactions happening. So this is how Herms work, and Herms basically works for Herms API. You cannot deploy a smart contract on ZK rollups yet. Okay, uh, ZK rollup technology currently is only supporting these NFTs, ERC20 and ERC1155, which is basically like token transfers, because uh, generating proof of uh, arbitrary smart contract logic is yet to be discovered or built. Okay, it's not easy to prove LHS is equal to RHS for everything as of now. Maybe in future this will be built, but currently we are able to prove LHS is equal to RHS without data for ERC20 transactions, basically mostly deposit, transfer, and withdrawal transactions, not beyond that. Okay, maybe a little more has been happening, but we are not able to generate these ZK snark proofs and all that. Maybe in research this has happened, but not currently in like market. Any such technology has come where any smart contract logic you are putting, we are able to do this ZK snark. We are able to generate ZK snark proof of that. It is not easy because you can write any kind of functions, you can provide any types of parameters in the smart contract, and that can return any data. So, and making a technology where you do not provide any data and you are able to prove LHS is equal to RHS, it is still under the work and research. But yes, Herms, Polygon Edge, and Polygon Herms, all these are able to provide you token transfer uh, using ZK rollups. So if your application only wants to transfer ERC20 tokens to another person or wants to transfer NFTs, uh, then you can use Polygon Herms. And if you want private transaction, you can use Polygon Edge. Okay. Oh, sorry, not Polygon Edge. It's Polygon Nightfall. So you can use any like that. So let me go to the next one. So in optimistic rollups, you can see like optimistic, that was ZK rollup. In optimistic rollups, basically uh, you can have like transaction. Basically, you aggregate the transaction and you basically submit it to the layer one directly. Okay, transaction call data. We basically call it as transaction call data. So in we submitted in Ethereum layer one, and we have then fraud proof challenges being done where like we basically submit fraud proofs and like challenges submit fraud proofs, and if it is correct, then we basically roll up the layer two transaction back to the uh, layer one. So that is what is happening on optimistic rollups. There is no kind of ZK snark proof happening on optimistic rollups. It is not present here. It is just like we are aggregating data, we are making it into the Merkel tree, and then we are basically uh, like uh, putting it as a call data in the rollup smart contract. So let's come to the what are the advantages of optimistic rollups. Okay, so let's come to the disadvantages also, advantages and disadvantages of these two kinds of rollups. One is there is low gas fee in optimistic rollups. Okay, there is increased throughput, smart contract capabilities there. Okay, yeah, the this thing I missed, like in as I said in ZK rollup, smart contract functionality is not there because we are not able to generate ZK snark proofs for smart contract functions and all that. We are able to do only for ERC20 and that. But optimistic rollups doesn't include any proofs, ZK snark proofs and like that. So we are able to build EVMs in optimistic rollup chains. So you might have heard about Arbitrium and those Metis. So they provide you with the smart contract functionality. So that is just because uh, like you are able to because optimistic rollup doesn't need ZK snark. So you can deploy smart contracts in optimistic rollup chains, but you cannot deploy smart contracts in ZK rollup chain. Okay. So security is guaranteed by Ethereum mainnet. That is by default for rollups. What are the disadvantages of optimistic rollups? Long withdrawal time. Challenge period can last for weeks. Okay. Some do challenge period for only 5 days, 2 days, 3 days. Some do for 1 month also. So it depends upon the chain and their logic. But yeah, that is basically a problem. Like if a fraudulent transaction is discovered, the rollup will automatically call a fraud proof and run the transaction from the. So this creates a long withdrawal times, and that is basically a biggest disadvantages of optimistic rollups. ZK rollups have naturally higher fees, okay, higher network fees than optimistic rollups because of the proofs that we have to generate. This optimistic rollups is like a Merkel tree snapshot, okay, a Merkel tree root hash. But in ZK rollups, we have these proofs also, and proofs are like quite larger in size. So that's why ZK rollups takes a little bit more fees than optimistic rollups. But yes, it is way more less than a direct Ethereum transaction. Okay. So advantages of ZK rollups are near instant transfers. You can withdraw, deposit very efficient, like quickly, because everything is computed and proofs are computed beforehand. It is not like you have to wait for 7 days to prove something. It is not mostly vulnerable to attacks. Okay, optimistic rollups are vulnerable to attacks because it assumes all transactions are correct. But ZK proof doesn't assume all transactions is correct. It computes it, it checks it, it verifies it, and then submits proof. So it is like there is no attacks, mostly no negligible attacks in ZK rollups transaction, and it's still secure and decentralized totally. It is inherent layer one technology. Disadvantages of ZK rollups. So like validity proofs that we generate in ZK rollups is not like good for smaller applications. Okay, if you do not, if you're uh, like if you have like less on-chain data, then it becomes very costly for you to use ZK rollups. Okay, if your application is small, data is small, then ZK rollups become like are extreme to compute for smaller applications. It's not like you can uh, reduce fee. Actually, it will increase the fee for you. Then the thing is like a user can influence the transaction ordering. Okay, in ZK rollups, as I said, that the sequencers and producers, block producers, and all that, they aggregate and sequence the data. So they have some influence over the ordering of transactions. So they can try to cancel some transactions and do the stuff. So that is there. So a little bit disadvantages on that side. And the third thing is like it still not support Ethereum virtual machine. Okay, because we are not able to like generate proofs for it, because a person can write any kind of logic, and building an automatic solution for that we are able to prove it. It's not yet built and there. So if we just have a table, that rollup is quicker, optimistic rollup is less fast, that rollup that everyone is legate, optimistic rollup everything is legate. Okay, and can directly transactions on L1, and it executes smart contracts on the L1. And the problem is like big spike transactions of inside rollups. And I think we almost covered all the differences that is present in ZK rollup and uh, optimistic rollups. So if we have another, like what is the speed and all that, 3 to 14 days of transaction finality is there in optimistic rollup. That is not present in ZK rollups. And some ZK rollups blockchain are actually private also. And that is the example of Polygon Nightfall. Polygon Nightfall allows you to do ZK rollup transaction having uh, privacy with it. Okay, so nobody would be able to know who you are transferring, who you are making a transfer of tokens. So that is what Polygon Nightfall is coming up. It is still, it is in mainnet beta, I think. Okay, it is in mainnet beta. But the thing is like whatever transactions you do on Nightfall, they are private. So you will not be, one person will not be able to know okay how much you transfer to another person, but you can only do transfers, not beyond that. On Nightfall, deposit and withdrawal is like from layer 1 to layer 2 and layer 2 back to layer 1. So that is there. And Ethereum virtual machine is present in optimistic rollups but not yet in ZK rollups. And there is easy wallet support for optimistic rollups but not for ZK rollups. It's a bit difficult, and we have to build our own. And the trust mechanism is validity proof, and here it is fraud proof with 7-day challenge period. And if you see the transactions per second, it is more in ZK rollups as compared to optimistic rollups, which is less than 200. So it's like difference between side chains, plasma chain, ZK rollup, optimistic rollup. Data on chain, okay, data resides on chain in ZK rollup using snaps. In part 2 optimistic rollup, data off chain, it's Palladium and Plasma. Okay, Plasma is like using fraud proof, like for snapshots, as I said, and this is Validium. If you see the market cap, it is sometime back report. So Arbitrium, these are like going up very fast, uh, like optimistic rollup. You can see Arbitrium has like total value logged is like 3.32 billion. So market share is very high for Arbitrium, which is an optimistic rollup. Then there is like DYDX, ZK rollups. So these are like coming into the space and might replace all the side chains and plasma chains that are currently in the market, because these are more secure and more faster, less gas costs than what sidechain provides also. And mostly the security is there. So security makes them more better than what sidechains and other chains are doing. and these are like ZK Stake, ZK Sync, and Boba Network, and Blueprint. All these are, there are more Polygon Herms, Polygon Edge. So they are also slowly uh, gathering the pace. So some of the Ethereum scalability solutions provided by Polygon, I have also worked on some of them. So this is the old one, Polygon POS sidechain, but this is Polygon Herms, ZK Rollup. Okay, this is Polygon Nightfall, ZK Rollup plus privacy. Harms is without privacy. Privacy means everyone can see whom you have transferred the tokens. But on Nightfall, you would not be able to see whom you have transferred the tokens. And then there is like Polygon Zero also coming, which is like more efficient than what Polygon Nightfall is. So thank you. And any questions, Pratik? And like, I hope you understood all about the rollups and these things.
Yeah, indeed. Thank you, Mohit, for that. That very informative talk, and thank you for your time today with us.
Yeah.
So probably I did ask you questions in between also.
Yeah.
So probably just a couple of questions towards the end. So we are now seeing layer three kind of blockchain
Hmm.
also coming up. So what are your views on that? And are we going to see layer four, five, or how do you think that's going to work out?
Yeah, there are layer three have come also, mostly in like there is like different kind of blockchain also coming that says they are like challengers of Ethereum, they are challengers of these technologies. Mostly we will see layer two, layer three, layer four in time to come. Okay, that is my idea, and I think we need it because in last 1 and 2 years only I can see so many applications being built on blockchain. Okay, people are migrating. Maybe we can say it's a boom. Okay, it's a hype in the current space, but whatever it is, I don't think the current blockchain is ready to accept that much of applications. Okay, it is not, I think, designed. We recently heard about Solana also being like getting down multiple times because of the load of transactions that are happening. So I think more and more solutions we need. We need privacy as well, and we need like a better technology as well, which can handle the pace and the speed that we have currently in Web2. And I am hoping like in next 2 3 years we would be having very fast, maybe layer two solutions as well as layer one solutions as well.
Right, that's great to know. So, what are your views on the current state of technology that we have? So there are, as of today, there are scalability issues. There is an issue of the speed of the transactions and kind of the speed of settling everything. So, so these are the kind of drawbacks over centralized database system, and the benefits are it's centralized, it's security and all those things. So, do you think that these blockchain or these kind of data blockchains can compete with centralized system on every aspect, and do you think they can surpass centralized system?
Uh, See, I feel like many people try to replace Web2 with Web3. Okay, I don't think like it would be able to completely replace it. Okay, they mostly it is like they would work in parallel. We are building Web3 because we want more security, more user control in the applications we are building. Currently, at the stage we have, like it is not at the power of what Web2 wants. Okay, we can do very quick transactions on Web2, and there the ecosystem is also not built to the level we need or the mass adoption of Web3. But yes, I feel like in next 3 4 years, okay, we would be like having a mass adoption coming up in Web3 technologies, and mostly it would be on the security part. Okay, it would be like all currently the applications are centralized and being controlled. We are moving towards a era where we don't have so much control over these institutions, mostly for financial stuff and whatever data we are doing. We will be controlling our own data. We would be controlling our whatever we are actions we are doing on blockchain. So that is what I feel. Currently, it is not at that pace, but as we can see, ZK rollup has come, Snark proofs have come, more and more things will come, which will actually increase the speed throughput of blockchain. And at one time, it is for sure that it will match with what Web2 is, and it will actually boost the Web2 stuff with the security. We basically lack in the security perspective in Web2.
Right. So, with that, thank you very much for being on the show. And it was a pleasure to interact with you.
Thank you so much. It was like great to talk to you and thanks for the invitation. Thank you.